Lesson 3.5, Arithmetic Sequences as Linear Functions. In this video, you will learn to recognize arithmetic sequences and relate arithmetic sequences to linear functions. Okay. So vocabulary includes sequence, terms of the sequence, arithmetic sequence, common difference, recursive formula. Okay, so first thing we have to understand is what an arithmetic sequence is. So if you think about arithmetic is adding and subtracting. So an arithmetic sequence is a numerical pattern that increases or decreases at a constant rate called the common difference. So if you're going from 3 to 5 to 7 to 9 to 11, each time it increases by the same number. It increases by 2. You're adding 2 each time, which means your D, your common difference, we call it D, is 2. It's the same thing for subtraction. So from 33 to 29, 25, 21, 17, each time it is decreasing by 4. You're subtracting 4. So your common difference is -4. Okay, so if it follows that pattern of just adding or subtracting a constant number each time, it is an arithmetic sequence. So we're looking at this. If we want to know if this is an arithmetic sequence, we're going to think, okay, what are we doing going from 15 to 13? We add 2. From 13 to negative 13 to -11, again, we add 2. From -11 to -9, we add 2. So following this pattern, is this an arithmetic sequence? Yes, because you're constantly adding a positive 2. It's consistent. Okay. What about this one? So going from 7/8 to 5/8, it went down 2/8 or 1/4, right? From 5/8 to 1/8, it went down 4/8 or 1/2. So because 2/8 and is not equal to 4/8, it is not an arithmetic sequence. Okay. Okay, so given that this is an arithmetic sequence, I want to be able to find the next term, right? So the next 3 terms in this case, going from -8 to -11, that went down 3. Again, it went down 3, down 3. So the next one is going to be subtracting 3 from 17, -17. So I'm going to get -20. So the next one is going to be -23, and the next one, -26. Okay, so those are going to be the next 3 terms in the sequence. Now this pattern works well for when you have just to get the next couple ones that are listed. But if you wanted to find like the 100th term, this would be a little difficult. So there's an equation that we can use to do that. So the equation is a of n, where n represents what term it is. So like this, like if I had a10, it's the 10th term in the sequence that we just called a. Okay, so it's going to be, the equation is whatever term I'm looking for is going to be the first term plus the number of terms the number term I'm trying to find, n, minus 1 times the difference. Okay, so if we're looking at this specifically, the equation that we're going to use is an equals a1 plus n minus 1 times d. Okay, so going from 1 to 10, it goes up by 9. 10 to 19 is 9, 19 to 29 is 9. So that means my d is 9. Okay, so I'm trying to figure out what the nth term is, right? That's an equation. All right, a1 is the first term in the sequence. So in our case, a1 is 1. So our equation is going to be an equals 1 plus n minus 1 times d, which is 9. So if I just wanted to clean this up a bit, this is going to be 1 plus 9n minus 9, or an is going to be 9n minus 8, combining like terms with the 1 and the -9. Okay, So this will give me an equation to find the nth term of the sequence. So if I want to find the 12th term of the sequence, my equation was an equals 9n minus 8. So an equals 9n minus 8. So that means if I'm trying to find the 12th term, n is 12. So the 12th term of the sequence A is 9 times 12 minus 8. So 9 times 12 is 108. Minus 8, so A12 is going to be 100. Okay, I also want to be able to graph terms. So the way we graph is we have an axis, an axis